We all grow up learning that gravity is this constant, unwavering force that holds us to the ground. Simple, right? But what if I told you that's not the whole story? What if that fundamental force isn't nearly as constant as you think? So let's ask a really simple question, or at least it seems simple. Is gravity the same everywhere on Earth? I mean, if you drop a ball in one place, does it fall with the exact same force as it would on the other side of the world? And the answer, which might just surprise you, is a definite no. The force of gravity actually shifts and changes all across the globe. There's this hidden landscape of gravitational peaks and valleys that we're living on top of. These subtle little shifts are called gravity anomalies. And they aren't just some weird scientific trivia. No, they're more like fingerprints left behind by incredible geological forces. And they tell us these deep, fascinating stories about our planet's past, its present, and even what its future might look like. So you're probably wondering, what's making Earth's poles so inconsistent? Well, it really boils down to three key ideas: how much stuff or mass is beneath your feet, how far you are from the planet's center, and the actual shape of the Earth itself. Okay, so let's get a solid definition down. A gravity anomaly is just a spot where gravity is a tiny bit stronger, we call that a positive anomaly, or a bit weaker, a negative one, compared to the average. It's all about how mass is spread out under the surface. We all have that textbook image of Earth as a perfect, smooth sphere, right? Where gravity pulls the same everywhere. But the reality is, well, it's a lot messier. Earth is actually what's known as an oblate spheroid. It's kind of squashed and it bulges at the equator. When you add in giant mountains and super deep ocean trenches, you get a really lumpy, uneven distribution of mass. And that right there is the fundamental reason gravity changes from place to place. But it's not just one thing. You've got massive mountains adding extra mass in some places. And then there's the Earth's rotation, which creates a centrifugal force that slightly counteracts gravity, an effect that's strongest at the equator. And deep down, the planet's mantle is churning like a thick soup, creating hotter, less dense areas and cooler, denser ones. All of this affects the pull we feel way up here on the surface. All right, now that we've got the basics covered, let's do the fun part. Let's take a quick tour of some of the most bizarre and fascinating gravity hotspots on the planet. These are the places that tell a really incredible story. Our first stop is Hudson Bay, Canada. Now, you'd look at it on a map and think nothing of it. But it's actually one of the biggest negative gravity anomalies we've found on land. And the reason why is pretty cool. It's basically haunted by the ghost of the last ice age. So here's what happened. Thousands of years ago, a colossal ice sheet, miles thick, sat on top of this region, literally pushing the Earth's crust down. When all that ice melted, the weight was gone, and the crust started to slowly spring back up. But the gooey mantle rock underneath is taking its sweet time flowing back in to fill the gap. This leaves a mass deficit. There is literally less stuff under Hudson Bay, and so you get weaker gravity. It's like a slow-motion geological echo. Okay, for our next stop, we're headed out to sea, to something that is truly mind-boggling. It's a massive gravity hole out in the Indian Ocean, a place where the planet's pull is just significantly weaker. The effect is so dramatic that the sea level itself is actually depressed by up to 100 meters. 100 meters! The best theory we've got is that it's caused by plumes of hot, less dense rock rising up from deep within the Earth's mantle. It's an incredible sign of the slow-motion engine that drives our entire planet. Now, you've probably heard of these tourist spots, right? Gravity hills or mystery spots, where it looks like a car in neutral is rolling uphill, completely defying gravity. So, are these for real? The short answer? Nah, they're just a fantastic optical illusion. The surrounding landscape, the way the trees are leaning or how the horizon is shaped, it just tricks your brain into misjudging the slope. If you brought a scientific instrument there, it would show you that gravity is perfectly normal. It's a cool trick, but it's not a real anomaly. So, these anomalies aren't just ancient geological relics. They're actually dynamic. They're changing right now in our lifetimes. And a huge reason for that change is the movement of one very important thing: water. Just look at Greenland. As its massive ice sheet melts, billions of tons of mass, of frozen water, are being removed and redistributed into the oceans. We actually have satellites that can measure this. They've detected a steady decline in the gravitational pull over Greenland. It's direct, undeniable proof of mass loss on a truly staggering scale. And this isn't just about melting ice. Human activity is having a measurable effect too. In places like California's Central Valley, decades of pumping groundwater for agriculture has removed a ridiculous amount of mass from underground aquifers. And here's the direct result. Just like with Greenland's ice, taking away all that water mass has caused the local gravitational pull to get measurably weaker. Just think about that for a second. We are literally changing the planet's gravitational field just by pumping water. That's wild. Okay, so this all begs the question, why does any of this matter? Well, it matters because being able to study this hidden gravity map gives us an incredible toolkit for understanding our world in ways we just couldn't before. And this is the real takeaway. These subtle changes in gravity help us find natural resources, like dense minerals or less dense pockets of oil. They let us track the real-time impacts of climate change. They help us understand tectonic plates and earthquake risks, map out ancient asteroid craters hidden beneath the surface, and even monitor when magma is moving underneath a volcano. It's an absolutely crucial tool. So, in the end, that's what gravity anomalies are. They're the fingerprints of a living, dynamic planet. They show us everything from the deep, hidden roots of mountain ranges to the faint scar left behind by the asteroid that wiped out the dinosaurs. It just goes to show that even the most fundamental force we know has this incredibly complex and evolving story to tell. And it leaves you wondering, right? By reading this invisible map, what other amazing secrets about our planet are just waiting to be discovered?